Boys and girls, today we are going to start talking about distance and time graphs. So we have talked a lot about distance and time as we've been talking about force and motion. We know that we use our distance and time to calculate something. We talked about it a lot last week, and that is our speed. So when we look at distance and time graphs, that shows us how long it takes an object to travel a certain distance. We have our x-axis and our y-axis. We always need to look at them and see how they're labeled. Sometimes our time, like here, is in hours. Sometimes it's in seconds, minutes. It varies on whatever is happening. Distance. This one is kilometers. We can have miles, feet, meters. Always look to see what it is that they're using to represent those. This is our x-axis and our y-axis. You probably remember that from math. I know that you guys have made coordinates. We will be doing coordinates later in math this year. And we know we always look at our x-axis and then go up to our y-axis, just like we do in math. Now in this case, you can look either one. So like right here, I know in 4 hours, go straight up, they have gone 4 kilometers. And if I keep looking at that, I can figure out a speed that they're going. Okay, so what can we calculate using distance and time? We know that's speed. We've been doing that for a while here. We talked about miles per hour. We say that a lot when we're riding in a car. Miles is our distance, hour is our time, and we say we're going 55 miles per hour. 55 is our speed. Okay, here on this chart, we see different types of constant speed. Constant. Have you ever heard your parents say, "You are constantly bugging me," or somebody is constantly calling them, or constantly doing something? It means they are continuing to do that. So something is at a constant speed. It's continuing at that same speed. So if you are a runner, you try to have a constant speed. Most of the time you get a little slower, get a little faster. There probably are times where you're constant. If you are riding in a car and they have cruise control, that helps you ride at a constant speed because it holds your vehicle at that speed, so it stays constant, 55 miles an hour. So if we see here on ours, we see a yellow line, a blue line, and a pink line. The steeper your line is, okay, think about it like a ramp. The higher it is, the steeper it is, the faster you're going. And that makes sense. Always look at it to help you see. So let's look at all of these because all of these lines end at our 10 seconds. So if you're confused on which one's going the fastest, read it and figure out where they're at. So our pink one, in 10 seconds, they went 10, and it's not labeled, we'll say feet. 10 seconds, they went 10 feet. So they went maybe 1 foot per second. 1, 2, 3, 4. The blue one, in 10 seconds, has gone 20 feet. So you can see here, excuse me, that if they go 20 feet in 2 seconds, then they went 2 feet per second. They were going a little faster. And the yellow line is at 30. So they went If they went 30 feet in 10 seconds, then they went 3 feet per second to get all the way here to 10. So that makes sense that they're faster. They got there after 10 seconds. They had gone much farther. We're still showing the same amount of seconds, but they had gone a lot farther at this time. Which object is faster? So we have our red and our green. Again, think about it. Now we talked about it being steeper. So don't look at it and just try to see which one is longer, or let's think about what it's saying. So they both started here at 0. And A, the red one, in 5 seconds had gone 30 meters. It took the green one 15 seconds to go 30 meters. So the red one is faster because it went the same distance in less time. And it is steeper. It's going straight up. Okay? We're going to skip that one. All right, stationary objects. A flat horizontal line shows something that is stationary. A stationary means it's not moving. You may have heard somebody talk about a stationary bike. That's a bike you ride on that doesn't move. You're still doing the cycling motion, but you're not going anywhere. The time keeps moving, the distance stays the same. I always just look, if I'm a little confused, look at it. At 0 seconds, they are, we'll say feet again. They're at 10 feet. At 1 second, they're at 10 feet. At 2 seconds, 10 feet. 3 seconds, 10 feet. 4 seconds, 10 feet. They haven't moved. Time is going, but they have not moved. So that is when it's stationary. If you see that straight, flat, horizontal line, that means they're not moving. But always check. Well, at 5 seconds, 10. 6 seconds, 10. They have not moved. Sometimes we will see an acceleration on our graph. So that is this curved line. Now, if it's curving steep or up, that means it's accelerating. The steeper the line gets, the faster it's moving. So here we can see at 1 second, we're maybe at 1 meter, 2 seconds, maybe 2, 3 seconds, maybe 4, 4 seconds, maybe 7, 5 seconds, they're at 15. So they started going way faster. Deceleration or decelerating is a curved line going down. So it's the same thing, they're slowing down. And you'll see that in a curved line. We also see in these graphs changing direction. So we see that there's a jogger chasing a pesky rabbit. So here's our jogger, started B, C, D. Our question says, what is happening between C and D? Okay, well, let's think about it. Let's start at the beginning. From A to B, what's happening here? My jogger was at 0, at 10 seconds was at 20 meters, 20 seconds was at 40, 30 seconds was at 60. They were moving at a constant speed. You see that straight line? They were moving 20 meters every 10 seconds. We saw that 20, 40, 60. What's happening from B to C? At 30 seconds, they're at 60. 40 seconds, they're at 60. 50 seconds, they're at 60. Right there, that was stationary. They were not moving. Time is going on, but they are not moving. So from C to D, look, our distance is going down. We were at 60 meters. We're going down. We're at 30. We're at 0. That means they're going back to the starting point. We were We started at 0. We went 60 meters. We're going back. We were 60 meters away, then 50, 40, 30, on and on until we got back to 0. And we can see that they were not moving as fast on the way back. It's not as steep as the line as it was here. Okay. And we just did that. All right. Let's look at this. A man walking a cat. My little girl loves to try and walk our cat on a leash. Our cat, Panther, does not like that, but Lainey loves to try. All right, so man walking a cat. What is the speed of the man during the first 3 seconds? Okay, 1, 2, 3 seconds. I see that right here. So I am looking at this line. At 1 second, 4 meters, 2 seconds, 8 meters, 3 seconds, 12 meters. I know the way to find speed is distance divided by time. So at 12 meters divided by 3 seconds, that's 4 meters per second. That would be our speed, 4 meters per second. It's a constant speed. Went 4 in the first second, 4 more in the second, 4 more in the third. What is the man doing between 3 and 5 seconds? Find it on your graph. Here's 3 seconds, 4 seconds, 5 seconds. That man is stationary. He is not moving. He's not moving. Maybe the cat is laying down getting a belly rub. And number 3 says, calculate the speed of the man between 5 and 7 seconds. So at 5 seconds, he is not moving. At 6 seconds, move 6 meters. 7 seconds, he is back at home, back where we started from. So what is the total distance that he moved? The total distance. He was here, he went 12 meters, stayed still, so there's no movement here, then went back home 12 more, so 12 plus 12 would be 24 meters. So you can see there's a little bit of math going into this as well as we've seen in a few other things. We're calculating that speed. Sometimes we just need to look and see the distance. So this last image that I'm going to show you is one that you have in your notes. This is very important. Our straight line means constant speed, like we see here on red. That's a straight constant speed. This green is a faster constant speed. The steeper the line, the faster the motion, just like our green one. It's taking them a lot less time to get farther. Look at red and green. It took this much time for red to get there. Or in this much time, red is only that far, green is way farther. A flat line, like we see here, this means stationary, not moving. Remember to read it. 2 seconds, same. Curved line. We can see accelerating in this one, accelerating. We're getting faster. It's not a constant speed anymore. It's not straight. You're getting faster. And then if we are going back down, we are returning to start. We're returning to our start, changing our direction, coming back home. So definitely knowing what these lines look like is helpful, but you don't feel like you need to memorize this. Just read your graph. At what time, what distance, and then you can compare those and help answer some questions about it.